Paraffin is stored in a tank with a horizontal base. At time t minutes, the depth of paraffin in the tank is x centimeters. When t equals 0, x equals 72 centimeters, there is a tap in the side of the tank through which the paraffin can flow. When the tap is opened, the flow of the paraffin is modelled by this differential equation. How long does it take for the level of the paraffin to fall from a depth of 72 centimeters to a depth of 35 centimeters? The tank is filled again to its original depth of 72 centimeters of paraffin, and the tap is then opened. The paraffin flows out until it stops. How long does this take? So I've got the summary of the question here. Basically, it said there's a tap in the side of the tank, so you can think of a tap being here. So when it flows out, the reason it says until the flow stops is because you haven't got the tap on the base itself, it's in the side of the base. So there will be a point at which the flow stops. So it doesn't say how long does it take for it to empty. And that's an important thing to note in part 2. So let's have a go at this then. The first part to begin with. How long does it take? So we need to solve this differential equation here, don't we? So here, separating the variables. So separating the variables and integrating. Gives. So let's have a look at this. So move the dt up to there and leave the dx as is. And then move the dt up, and we'll leave the minus 4 there. And we're going to move the other term, this term here, this object here, from times down to divide. So it will be 1 over x minus 8 to the power third. That's the variable separated then and integrating. So let's have a look at this. The left hand side is a function of a function. So we can write, this is minus third, isn't it, on our mind's eye. So add 1, you get 2/3. So that's the power we want to write down. When we differentiate, we get 2/3 of this to the minus 1/3, which is what we want. We've only got a 1, so we need a 3 over 2 here, so that we get 1 when the 2/3 comes down to multiply that. So it's 2/3 times 3 over 2, which is 1, this to the minus 1/3 multiplied by the something differentiated, which is 1. And that's fine. So that equals then, integrate this, minus 4t plus k. Now, at t equals 0, x is equal to 72. So we've got that initial condition. So let's substitute that in then. So let's see if we can do it. X is 72. 72 minus 8 is 64. So we've got power third of 64, haven't we? Which is 4, and then we square it, which is 16. 16 over 2 is 8, and 8 3s are 24. So you can tap that in the calculator if you need to. Just check it again. 72 minus 8 is 64. 64 to the third is 4. 4 squared is 16. 16 over 2 is 8, and 8 3s are 24. And then t is 0 in here. 4 noughts are 0 plus k, so k is 24. So we've got our constant value here, so we can write down our particular solution for this differential equation then. 3 over 2, x minus 8 to the 2/3 is equal to 24, we'll write first, minus the 4t. So as x decreases from 72 down to a value, we've got t is equal to this value. So can you see that the way it's arranged, that the tap looks like it's going to be at height 8, doesn't it? Because that will be when this turns negative. And so x can come down to 8, I presume, by the way this differential equation is modelled. So that's implicit in the differential equation itself. It's something we need to note for part 2. So 35, let's put in 35 for part 1 now. Here, x equals 35 then, gives, again, let's put it in, 35 minus 8 is 27. 27 cube rooted is 3, and 3 squared is 9. 9 times 3 is 27, so it's 27 over 2 is equal to 24 minus 4t. So that tells us then, move the 4t over here. plus 4t. Write this as halves because you got a half there, so it's 48 over 2. That's the 24, and then move this over to be with the 24, so it's minus 27 over 2. So that tells us then that 4t is equal to 21 over 2. And finally move the 4 from times to divide. T is equal to 21 over 8, and I think it was minutes, wasn't it? Time units anyways. So there's the time then, when it gets down to 35 centimeters. Now, part 2, we said about that. It isn't when the tank is empty, it's when the flow stops, and that we presume is when x equals 8, and that was observed by looking at the solution of the differential equation, how it is. So, okay, so that's what we've got. So go back to the original question. You can see it here. dx dt is minus 4 times this. So it will stop. The rate of flow will be negative from x down to 8. And then it will stop. So that's inferred from the differential equation there. So let's have a look then. X equal to 8 then gives, and see what we get. Put 8 in, and we simply get a 0 here, don't we? So 0 equals 24 minus 4t. So that tells us that 4t, move it over to the other side, is equal to the 24. And that tells us move the 4 from times to divide. 24 over 4 is 6. So that's 6 minutes.